Unit 5 in Animal Science focuses on growth and development, and that's Chapter 18 in your textbook. I'll motor right on past the objectives. You all can review those in your note packet. Some introductory concepts here in this section is that profitable and very efficient livestock producers really know how to get the most out of growing and developing their animals, and especially their young stock. It's not as easy as it sounds all the time that we just do a few specific things and everybody will be very, very good at growing animals. It takes some very good focus on specific attention to detail in a lot of different areas. And if you want to consider species-specific growth, we'll get into that in much more detail later on in the semester. So if we define both growth and development, growth is simply obviously increasing size and body weight. Development includes that growth, but also includes cellular differentiation and changes in shape and form of the animal. 3 phases to prenatal growth. Of course, we have growth of sex cells, the embryo, and the fetus. So obviously there's big time changes occurring during the prenatal period, but tends to follow the order of we develop the central nervous system first, then the internal organs, then bones, tendons, so on and so forth, and fat is accumulated later on. And that fat is really, really important, actually. You wouldn't think that the developing fetus carries very much fat, but what they have is what they call brown fat, and that is essential for whenever they're just born. That's kind of their first original energy source before they start consuming colostrum and milk to help support them. So the first 2/3 of gestational growth, we have what we call hyperplasia. So we're increasing the number of the muscle fibers. The last third of gestation and prenatal growth is what we call hypertrophy, where you increase the size of those muscle fibers. And fetal development, the last third of gestation, is very exponential. That's the fastest growth period. So we'll go from something relatively small at the start of the last trimester to essentially that full-grown, fully developed calf or fully developed baby pig or whatever it may be. Here's a diagram that shows a little bit about that in terms of how the cells differentiate and what it may look like from start to finish. A little bit also, I mentioned the exponential nature of how those things grow, and you'll notice the length in inches, more or less linear, but gets at a pretty fast rate. Look at the weight. It's pretty steady from 0 to about 4.5, maybe 5 months of age in terms of what the weight of that baby calf may be in womb or in utero, as we call it, and then it just grows exponentially to that 9-month period where you might have then an 80-pound calf born. Birth in livestock, again, the number of muscle fibers, just simple muscle fibers, is pretty much set at birth. There isn't really a lot of additional muscle fibers added after birth. So increasing the size of those muscle fibers is what accounts for growth. And your book proposes here is a kind of a guideline of what animals may weigh, how long they might be, how tall they might be, and their width as a percent of mature size. Poultry, then, that blastoderm piece of the egg is what develops into the chick embryo. And incubation in poultry needs to be between about 99 and 100 degrees Fahrenheit, very specific relative humidity, and turning that egg every few hours with adequate oxygen will help in proper chick development. A little just basic anatomy and physiology. If we look at the skeletal system, obviously that provides our basic form and shape and protects all the vital organs that are in there. A storehouse for key minerals, and you have to remember back to the nutrition section, sometimes the body calls upon the bones to draw out some key minerals that maybe aren't supplied or supplied in great enough quantity in order to meet nutritional demand. So that's somewhat of a storehouse for some of the key nutrients sometimes for the animal. Chicken bones obviously are much more hollow, thinner, and more brittle, and don't store quite as much material as what a non-poultry animal might be. It's just a skeletal system of the horse breakdown, and you'll see a lot of similarities. If we put all the other ones up here, I think I just threw this one in here just to have you something to look at. The muscle system, and many of you have covered maybe some of this in basic biology class, but again, we have skeletal muscles, which is the largest muscle component of the body. Smooth muscle, which basically makes up your digestive tract, reproductive tracts, and the urinary system. And then your cardiac muscle. The cardiac, obviously the heart, the only one in the body that looks like that. Very, very specialized because it has a lot of different responsibilities that no other muscle in the body clearly has. Bottom line is the role of muscle is to convert what we provide in terms of nutrition and chemical energy to mechanical energy. It's taking what's there in energy and protein and vitamins and minerals, etc., and converting it into some kind of useful form, whether that's growing and making meat, or whether that's making milk or eggs or whatever it may be. So all of those performance parameters that we're going to measure throughout the rest of the semester when we talk species-specific production essentially boils down to these three things here. Power, which is the amount of work that could be accomplished in a fixed time period. Strength, which is the result of muscle size and contractible force. And endurance, how long can they stand to do the kind of work or perform the kind of duties that we're asking them to without becoming significantly fatigued or impacted due to the capacity to store nutrients. So those are the big three things in general as we look at muscle function. Again, I thought I'd just throw a diagram out there that your book provides that throws you shows you some of the big primary muscles of a beef steer. The circulatory system, very quickly here, obviously arteries and veins, and you all understand this back from junior high biology class, but just a reminder that the circulatory system is your basic transportation module for all of the oxygen, nutrients, waste, don't forget that part, hormones throughout the body. So just a kind of a little fun fact, especially for milk producing animals, anything lactating. Like an example here, a cow needs about 400 to 500 pounds of blood to flow through the mammary system to make 1 pound of milk. So you know how quickly that stuff is circulating through. Just a real brief bullet point on the endocrine system, which relates to hormone function, and we'll deal with a lot of hormone function when we get to the reproductive section. But the chemical substances that are made by the body that impact virtually all body tissues in some way or another. We're going to primarily focus on, very simply, the reproductive system when we talk hormones, but there's many, many, many that go throughout the body that play very, very key roles. Here's just primary endocrine systems of a sheep, just to show you where many of those may lie and what they may do. A breakdown of a lot of the endocrine system hormones that you can see maybe what hormone it is, where they're made in the body, and what major effect that they have. If you're interested in this, in study of hormone usage and how to, magnify or amplify that hormone effect, there's lots of things that you can get into at the upper levels of animal sciences to figure out how do we influence hormonal balances and hormonal output. Growth curves, again, if we look at growth curves of most animals, very early on it's a pretty linear rate. They're going to grow at a very even and steady rate in most cases, unless we have improper nutrition or poor facilities. You should see a pretty linear growth rate. As we reach puberty, then the rates of growth decline and slow down, and true growth, meaning the true expansion of muscle fibers and bone tissue and so forth, basically ceases once an animal reaches maturity, whatever that may be. Now clearly that asks, well, what about fattened animals? Increasing weight, especially as a function of adding fat, is not really true growth. So there's really no net bodily increase in body protein when we are fattening out, say, steers or pigs. Carcass composition, and back to meats section, we've already talked a good bit about this, but carcass composition clearly is influenced by genetics, gender, frame size. The bottom line and point to this section of the PowerPoint is to reinforce that many times it doesn't matter what breed or combination of breeds an animal is, they finish basically at very similar carcass quality, which we kind of referred to back when we were talking in the meats section, is that Holsteins are crossbred or Angus beef or Herefords, they can all finish at very similar carcass quality, just very different weights. So it's quite different when you get to talking about frame size. Gender, clearly you have some differences in how quickly or slowly those animals will finish based upon gender. Here's just a good slide that comes out of your textbook, and I'm not going to go into this in detail because the graphs are somewhat small, but it gives you growth rates of all the major species that we're going to get into. Another one graph coming out of your textbook that shows tissue growth relative to increased live weight. You see the bright blue line is muscle tissue, the light blue line is fat, and then the orange line is bone tissue and how they may change over time. Same thing with swine here. Same thing, again, reflecting that frame size differences in animals and how that, eventually they're going to all finish at about the same type of carcass quality, just at very different weights. So kind of finishing up this section and talking about how to calculate average daily gain. And basically they're talking about end weight minus beginning weight divided by the difference in days equals your average daily gain. So I provide you an example here. If we weighed some steers that currently weigh about 650 pounds, and the last time we weighed them they weighed 500 pounds, and there was about a 50-day window in there in which those animals were growing, we do a little division there and we come up with an average daily gain of 3. It's important to know because, again, you can't manage what you don't measure. It's what a saying that Temple Grandin uses, and I can't encourage and underscore that enough, is if you're not measuring things like average daily gain or feed conversion or some kind of productivity on your operation, how do you change it? How do you know what to change? And so I wanted to reinforce how we go about calculating average daily gain. This will come in handy later on in the semester as we do a number of other activities. Some take-home messages to this section is just, again, clearly understand growth and development. It's really, really critical to managing your livestock operation. You can all pick out really good managers out there in the countryside that you know and respect and do great jobs at growing their livestock. And then you can all pick out some that, their animals tend to struggle for whatever reason. Find out the little secrets, the little tricks, the little tools that they use, and try and find ways to improve your own growth and development or be able to help more effectively producers that you may be working with. Growth and development, positively or negatively, can be influenced through management choices you make. And I referenced simply genetics, facilities, ventilation, nutrition, obviously. There's a whole bunch of them that go into play there. And then make those correct managerial adjustments because they clearly impact efficiency and profitability. Obviously, we're talking about the broadest sense of the word here when we talk growth and development. We haven't got into any species-specific growth. But find those managerial adjustments that you can make them, measure them, and improve upon them. I'll look forward to talking to you in class about how we address growth and development.